the sum and difference trig formulas. So if we have a value that's not on the unit circle but can be written as a sum or a difference of angles that are on the unit circle, we can solve it using the sum and difference formulas. So these formulas can be derived, and I encourage you, if you're interested, look and see how this formula comes to be. If we take the cosine of two angles, of the sum of two angles, or the difference of two angles, we get and we're taking the cosine, we get the cosine of the first angle times the cosine of the second angle. Now notice my plus and minus switched right here. That means if I have alpha plus beta, I'm going to end up with a minus right here. And if I have a minus, so I have alpha minus beta, I'm going to end up with a plus. Cosine beta plus minus plus sine alpha times sine of beta. So I have my cosine of my sum and difference, also my sine of my sum and difference. So alpha plus beta, or alpha minus beta, equals sine of the first angle times cosine of the second angle, and my sines stay the same. And I remember that because I'm doing sine. There's reasons behind that, but I remember it by knowing I'm doing sine of alpha plus beta. The sine stays the same. Cosine of the first angle, sine of the second angle. So with my cosine, I'm taking the cosine of both, switching the sine, and taking the sine of both angles. My sine switches, so sine and then cosine, cosine and then sine. So I'm using these when I can't find it on the unit circle, but can be written as a sum or a difference of something that can be. So for example, the cosine of 105. Now if you look on your unit circle, you won't find it there, but it can be written as the cosine of 150 degrees minus 45, or it could be written as the cosine of 60 degrees plus 45. That's still the same thing. And then I can use my formula up here in order to be able to calculate this without using a calculator. Sine of 75 degrees can be written as the sine of 30 degrees plus 45 degrees, or the sine of 120 minus 45. And you'll have to figure out how to rewrite this in terms of the unit circles. So for this one, I just subtracted 45 and I added 45 to see what ones I could come up with. So let's take a look at how this works in practice. So I'm going to use cosine, because I have the cosine of 105 degrees from before, so I'm going to use my cosine formula. And I'm going to rewrite this as 60 plus 45. I could have done the difference one, but I chose to do the sum. I usually choose to do the sum. It's easier for me to remember the signs that way, but you can do it either way and you'll get the same answer. So I have my cosine alpha, and alpha in this case is 60, beta is 45, times the cosine of my beta, which is 45, minus, my sign changes here, sine of my first angle, which is 60, times sine of my second angle, which is 45. Now 60 and 45 are on the unit circle, so I went ahead and drew them on the unit circle. So here my cosine of 60 degrees is just 1/2. Oops, I have this wrong right here. So this is 1/2, comma, rad 3 over 2. That's a common error to make which one. So I know that this is my cosine. My cosine's going to be shorter, my sine's going to be longer. So cosine of 60 is 1/2. Cosine of 45, that's my x value, is rad 2 over 2. They're the same in this case. Minus my sine of 60. Sine of 60 is my y value, rad 3 over 2, times my sine of 45. So sine of 45 is my y value for 45, which is rad 2 over rad 2. And then just multiplying my fractions, I have rad 2 over 4 minus rad 6 over 4. I'm going to put that under the same denominator, and I have rad 2 minus rad 6 all over 4. This is the exact value of the cosine of 105 degrees, and I didn't need to use the calculator. I could write it in terms of the sum of two angles. Let's look at a cosine example. So sine alpha plus or minus beta, and right here I chose 285. That was different from the first one on the first board, but this one's a little bit more complicated. I wanted to make sure I gave you a little more complicated example. So sine of 285, and I can rewrite that as sine of 240 plus 45. I could also rewrite that as a difference. I just chose to write it as a sum. And that's equal to, now I'm going to go sine cosine, so sine of my first angle times cosine of my second, sine of 240 times cosine of 45, plus, my sine stays the same, sine of 45, that's of my second angle, cosine of 240. So then I need to calculate what the sine of 240 degrees is. And I chose 240 degrees because it's on the unit circle, and so is 45. So 240 degrees is going to be all the way over to here. So I know this is 270, and that's minus 30 to get to 240. So I know this has to be a 60-degree angle, so all the way around there. So my cosine is going to be negative 1/2, and my sine is going to be negative square root of 3 over 2. And then for 45, that's a nice easy one. Rad 2 over rad 2, comma rad 2 over rad 2. That's my arc length and my angle. So here, sine of 240 is negative rad 3 over 2, times cosine of 45. Cosine of 45 is rad 2 over rad 2, rad 2 over 2, plus sine of 45, that's rad 2 over 2, times my negative 1/2. And it's negative because of the quadrant it's in. It's in that third quadrant. Okay, so then we go ahead and multiply. We have a negative rad 6 over 4, and we have negative rad 2 over 4, and that gives us a negative rad 6 minus rad 2 all over 4. So we can also go the other way. Sometimes, if we have angles like this, we can merge those together into an angle that we know. So this right here, I see I have cosine of one angle times the cosine of another, plus sine of that same first angle times the sine of another. So because of my formula, I know I'm going to be using cosine. Now you have to be really careful because I have a plus right here, but remember cosine switches that sign. So in between my cosine of my angles, I'm going to have a negative. I started with a positive, I'm going to have a negative right there. So cosine of alpha minus beta. So this one right here, I have my 80 degrees for alpha, I have my 20 degrees for cosine, and so I'm just, if I were to take this and expand it, it would turn into this up here. And then I can do 80 minus 20, and I have cosine of 60. So I couldn't find cosine of 80 on my unit circle, and I couldn't find cosine of 20 on my unit circle, but I can find cosine of 60. So on my unit circle, here's cosine of 60, and I have 1/2 comma rad 3 over 2. I'm looking at my x value on the unit circle, and that's just 1/2. Let's look at one more example. I don't usually use this formula for tangent just because it's a little complicated, and I often don't have to use it, but I know that you have some problems that you're going to be working with tonight. And so tangent of alpha minus beta equals tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta. So if we're given something like tangent of 195 degrees, well, 195 degrees isn't on the unit circle, so I'm not going to be able to take my y value over my x value. So that's when I'm going to use this formula. So tangent of 240 minus 45 degrees. So that's the same as 195. I just broke it up into 2. And I chose to use the subtraction here because it's given in the formula. So I tried to make it a subtraction problem. If I didn't want to use subtraction and I wanted to use addition, I would just have to make beta be a negative angle. So a negative negative would be a positive. Okay, so then I just substitute my values in. Tangent of 240 minus tangent of 45, just substituting alpha and beta, all over 1 plus tangent of 240 times tangent of 45. Now, probably the toughest part about this formula is to find the tangent of that angle. So 240 degrees is all the way over here, and I'm right here at 240 degrees. So I know this is 270, this is 30, that must be 60. So I have negative 1/2, comma, negative rad 3 over 2. 45 is nice and easy. I go to 45, I have rad 2 over 2, comma, rad 2 over 2. But now I need to find the tangent. So I need to take that y value over the x value. So negative rad 3 over 2 over negative 1/2. This is a complex fraction, so I'm going to take and turn this division problem. I have rad 3 over 2 divided by negative rad 3 over 2 divided by negative 1/2. I'm going to take that division problem, turn it into a multiplication problem, and so I have negative rad 3 over 2 times negative 2 over 1, multiply them through, my 2's make a 1, and I have tangent of 240 degrees is rad 3. And it's a positive rad 3 because I have a negative divided by a negative. Tangent of 45 is nice and easy because I have rad 2 over 2 over rad 2 over 2. Anything over itself is 1. Tangent of 45 is 1. So then I just substitute my values in. So tangent of 240 is just rad 3 minus 1, tangent of 45, 1 plus rad 3 times 1. Rad 3 times 1 is just rad 3. So we probably could just leave it like this unless we wanted to rationalize the denominator. If we want to rationalize this denominator, we have to multiply both the top and the bottom by the conjugate, which is 1 minus rad 3. So multiplying the top and the bottom, and I'm foiling here. So I'm foiling these two with each other, and I end up, after I combine like terms, getting 2 rad 3's. So I'm multiplying here, here's 1 rad 3, and here's another rad 3. Add them together, we get 2 rad 3. Minus 1, that negative 1 times that 1, minus 3. Rad 3 times a negative rad 3 is going to give me negative 3. And then on the bottom, I can just think about this as a difference of squares. So 1 minus, these two middle terms are going to cancel, so minus rad 3 times rad 3, which is just 3. So then just combining like terms, I have negative 4, I put my number out in front here. So this negative 1 plus the negative 3 is negative 4, plus, this one's positive, 2 rad 3, all over negative 2 because I have a 1 minus 3. And then dividing by negative 2, each of those terms, I have 2 minus rad 3. And that's in a lot simpler form than my original equation. Although this one would be very easy to plug into a calculator, but if you don't have a calculator, you can just rationalize the denominator, make it simpler.